I'm going to take both of these and just copy and paste them over to my abstract class. Because they're actually pretty close. Okay. All right, let me comment the hash code out, and we'll do that next. And let's focus on the equals method. So this stuff at the beginning, I do want this, all right? But now I want to check if these are general stacks, okay, not just array stacks. All right, so here's the first problem. I don't want to mess with array stacks at all. I don't want to say is object instance of array stack. I want to say is object instance of stack. All right, and if it isn't, I return false. But if it is, I'm going to cast that object to a stack rather than an array stack. Now, I still have a problem here. So my problem here is that capacity cannot be resolved to a variable, right? That's because the capacity variable is private and the capacity variable is part of array stack. Well, it turns out that even though we don't have access to a capacity variable, we do have access to a capacity method, all right, for all stacks. And so we can just call the method there and we get the same thing. All right, and now we can do the same for depth. We have access to a depth method. And amazing, that is now fixed. So now we have to worry about this where we just looked at certain elements of the array. Well, here's where our stack iterator is going to come to the rescue, because we're going to assume that anybody who has, well, we don't need to assume this, the compiler forces us to implement an iterator for stack. And we're going to assume that iterator, is written in a particular way where the first thing it returns is the bottom element of the stack, the second thing it returns is the one next to the bottom, and so on until it returns the last element of the stack. And remember, when I say returns, it's not going to remove it from the stack. Iterators don't, typically you don't want iterators to modify the stack. We're just going to get access to that element, and so that we can compare them with their equals methods. Okay, so here's how we're going to do that. We're going to actually use the for each loop for the current stack. So we're going to say e element for each element of this. We're going to compare it to each element of the other stack. To do that, we need to actually explicitly create an iterator for the other stack. Okay, we can't use the same for each loop. So here's a case where I think I've said before, if you can use a for each loop, if you can get away with using a for each loop instead of an iterator, that's the thing to do. Here's a case where for one of the stacks, we can get away with using the for each loop, but for the other one, we need to specifically declare an iterator. So I'm going to say, I'm going to call this other iterator, and that is going to be equal to other.iterator. Okay, and remember these question marks, we're just going to treat those like objects. All right, so this is not that hard to do. So simply now, we simply say if the elements of this equals the object of the other, and to get the next object of the other, we're just going to use the iterator. So we're going to call this other iterator.next. If it's equal, well, if it's equal, return true. That doesn't make sense. You just have to check if it's not equal, then return false. All right, then we can get rid of that. So basically, if the first element of the iterator, so first we're checking the first element of the iterator with the first element of the other iterator. So this is the first element of the first time through this loop. This will be the first element of this iterator, and this will be the first element of the other iterator. Right? The second time through the loop, this will be the second element of this iterator, and this will be the second element of the other iterator. All right? So that's exactly what we want to do, and I'm pretty sure that that is going to be our equals method, and that should work. Okay? So this should work no matter what type of object it is, because if it isn't a stack, it's going to be return false. And if it's any kind of stack, if it implements the stack interface, it will also have an iterator. Okay. Very good. So now let's do hash code. And I'm going to uncomment that. So it's given us this prime number here. It's starting with result equals 1. That's all good. We've got this prime equals capacity. I'm not sure we need this. Well, we can change the capacity to that. We can change depth to that. But we don't have this elements. All right, because this is not necessarily an array-based bounded stack. We want this to work for any kind of bounded stack. I'm not really sure if we need that depth in there, but it doesn't hurt to have it. So instead of getting the hash code for these elements, I'm going to iterate through this stack, and I'm going to keep adding the hash code for the individual elements of the stack. And in this case, I don't need to create an iterator. I can just use the for each loop. So I'm going to do that for each element in this result, and I'm just going to use the same format here. Result equals prime times result plus element dot hash code. And then I'm going to return result. Okay, there's one last thing I want to show you, and that is I want to show you that if you have the JDK installed, which you should have that installed, you can actually find the source code for most of the Java libraries. So you go to this PC if you're on Windows, and you click Windows C, you go to Program Files, go to Java, and there's all my JDKs and my JREs. The source code is not in the JREs. So I'm going to go to my JDK, And look at that. There's my zipped source code. And this is actually the source code for most of the Java libraries, which is an incredible, incredible resource. So I highly recommend that you take advantage of this. I'm going to double click on that. I know my utilities are in java.util. And look at all those. Look at all those sources. That is a great help because this tells you how the professional Java developers created these libraries. All right. So if I go to abstract list, there it is. There's my abstract list, Java util. Okay, you can see examples of Java docs. You can see an example of a constructor. So there's abstract list. And I'm going to go down to the equals method here. You can see they even implemented the iterator in the abstract list. A lot of stuff apparently is implemented in the abstract list. There's the set, and there's the equals method. Okay. And we can see that it looks, I mean, this is for a list, but you can see that this actually looks very similar to our stack iterator. Okay. And one of the things that I've looked at this before, and this is one of the reasons why I added those question marks, is sometimes it's hard to wrap your head around all the special cases of generic types, but I saw that they had the question marks in there, so that I put them in my code. So this is almost identical. There's a couple differences here. They do this kind of slick. They create iterators for both of these, and then they do while E1 has next and E2 has next. I mean, you can look at this yourself. It's an alternative way of doing the iterator, but of doing the equals method, but it's pretty similar. And we can see that they did the hash code also. So one thing I should mention is that they do this: if E equals null, then return 0. Okay, otherwise return the hash code. Well, and they do that up here in the equals method too. If they check if these things are null. The reason we don't have to do that in our code is because we have a requirement that you cannot insert null values into our bounded stack. All right, in a Java list, you are able to insert null values in there. Okay, so I just wanted to point that out if you decide to look at this code and you're saying, well, how come we don't have this E equals null thing? That's because we're not allowing null values in our bounded stack. Okay, so that's what I wanted to show you. And that's it. That's our equals method and our hash code method. In the next video, we will look at the toString method.